Assistant Professor at LJ Institute of Engineering and Technology. Today in application of integration, I will teach you new topic, that is length of plane curves, area of surface of solid of revolution. So let's start. Length of plane curves. So first of all, we will see how to find out the length of arc in Cartesian form. The length of the arc of the curve y equals to f of x between x equals to a and x equals to b is given by s, that is equals to integration from a to b square root of 1 plus dy by dx the whole square dx. Now we will see how to find out the length of arc in parametric form. The length of the arc of the curve between the points t equals to t1 and t equals to t2 is given by s equals to integration from t1 to t2 square root of dx by dt the whole square plus dy by dt the whole square dt. Now we will see how to find out the length of arc in polar form. The length of the arc of the curve r equals to f of theta between the points theta equals to theta 1 and theta equals to theta 2 is given by s equals to integration from theta 1 to theta 2 square root of r square plus dr by d theta the whole square d theta. Now we will see one example related to this topic. Find the length of the arc of the curve y equals to log sec x from x equals to 0 to x equals to pi by 3. So here is the solution. Here the given curve is y equals to log sec x. So first of all we will find out its derivative, that is dy by dx, and that is equals to, now derivative of log x, answer is 1 upon x, but here in place of x we have sec x, so derivative of log sec x, that is equals to 1 upon sec x, and in place of x we have sec x, so again we will differentiate sec x, and derivative of sec x is sec x into tan x. Now sec x will cancel out, so we have dy by dx, that is equals to tan x. For the required arc, x varies from 0 to pi by 3, which is given to us. Therefore the length of the arc s, that is equals to integration from 0 to pi by 3 square root of 1 plus dy by dx the whole square dx, and this is equals to integration from 0 to pi by 3 square root of 1 plus dy by dx is tan x, so it is tan square x, and dx will be as it is. Now all of you know the formula of 1 plus tan square x, that is sec square x, so square root of sec square x, the result is sec x. So this is equals to integration from 0 to pi by 3 sec x dx. Now we will integrate sec x with respect to x. So this is equals to integration of sec x, that is equals to logarithm of sec x plus tan x, and the limit is from 0 to pi by 3. Now we will evaluate this function for upper limit pi by 3 and for lower limit 0. Now if you will replace x by pi by 3, so it will become logarithm of sec pi by 3 plus tan pi by 3, and the value of sec pi by 3 is 2 and the value of tan pi by 3 is root 3. So it will become logarithm of 2 plus root 3. Then after minus sign, replacing x by 0, so it will become logarithm of sec 0 plus tan 0. Value of sec 0 is 1 and tan 0 is 0. So it will become log 1 and the value of log 1 is 0. So the overall result is logarithm of 2 plus root 3. So this is the required arc length of the given curve, that is y equals to log sec x from x equals to 0 to x equals to pi by. Now we will see how to find out area of surface of solid of revolution. Now first of all we will see how to find out the area of surface of solid of revolution in Cartesian form. Area of surface generated by revolving the arc of the curve y equals to f of x about the x-axis is given by s equals to integration from a to b 2 pi y square root of 1 plus dy by dx the whole square dx. Similarly, the area of the surface generated by revolving the arc of the curve x equals to f of y about the y-axis is given by s equals to integration from c to d 2 pi x square root of 1 plus dx by dy the whole square dy. Now we will see how to find out the area of surface of solid of revolution in parametric form. When the equation of the curve is given in parametric form, x equals to f1 of t, y equals to f2 of t, with t1 less than or equals to t less than or equals to t2, the area of surface of solid of revolution about the x-axis is given by s equals to integration from t1 to t2 2 pi y square root of dx by dt the whole square plus dy by dt the whole square dt. Now we will see how to find out the area of surface of solid of revolution in polar form. For the curve r equals to f of theta bounded between the radius vector theta equals to theta 1 and theta equals to theta 2, the area of the surface of the solid of revolution about the initial line theta equals to 0 is given by s equals to integration from theta 1 to theta 2 2 pi r sin theta square root of r square plus dr by d theta the whole square d theta. Now we will see the example related to this topic. Find the area of the surface of revolution generated by revolving the curve x equals to y cube from y equals to 0 to y equals to 2. So here is the solution. Here we have been given the curve x equals to y cube. So first of all we will find out its derivative with respect to y. Therefore dx by dy that is equals to derivative of y cube according to the formula d by dx x raised to n, that is n x raised to n minus 1, so it is 3y square. Now this is the graph of x equals to y cube, and this point is 0 0, whereas this point is 8 comma 2. When y equals to 0, replacing y by 0 in this function we have x equals to 0, and when y equals to 2, replacing y by 2 in this function we have x equals to 2 raised to 3, so it will become 8. So we have 2 points, one is 0 0 and other is 8 comma 2. The area of the surface is generated by revolving the region about the y-axis. For the region shown, y varies from 0 to 2. The area of the surface is generated by revolving the region, that is this one, about the y-axis. For the given region shown, y varies from 0 to 2. Here we have y equals to 0 and here we have y equals to 2. So the required surface area S, that is equals to integration from 0 to 2, because y will vary from 0 to 2, 2 pi x square root of 1 plus dx by dy the whole square dy. So this is equals to integration from 0 to 2, 2 pi and x equals to y cube. The square root of 1 plus dx by dy is 3y square, and we have its power 2 dy. Now this is equals to integration from 0 to 2. Now this function can be written as 1 plus 9y raised to 4 the whole raised to 1 by 2, and this y cube and 2 pi r as it is, and multiplying numerator and denominator by 36, because if you will consider this function as f of y, so its derivative will be 36y cubed. So for that purpose we have multiplied the numerator and denominator by 36. So this is equals to 2 pi by 36, that is pi by 18. Now this is function and this is the derivative of this function, and we have this formula of integration, that is integration of f of y the whole raised to n multiplied by its derivative, that is equals to f of y the whole raised to n plus 1 upon n plus 1, and this is f of y, that is 1 plus 9y raised to 4 the whole raised to 3 by 2, because 1 by 2 plus 1 is 3 by 2. Then after we have to divide this result by 3 by 2, and the limit is from 0 to 2. Now we have to simplify this result. We will multiply pi by 18 by 2 by 3, so it will become 2 pi by 54. Then after replacing y by upper limit 2, so 2 raised to 4, that is 16. 16 into 9, 144. 144 plus 1 is 145, and its power is 3 by 2. Then after 4, lower limit 0, 9y raised to 4 will become 0, and 1 raised to 3 by 2, that is 1. And 145 the whole raised to 3 by 2, that is nothing but 145 into square root of 145 minus 1. So this is the answer of given problem. So in today's lecture we have discussed how to find out the arc length and the area of the surface of solid of revolution, and we have gone through 2 examples related to this topic. Thank you for watching this video. I will see you in the next lecture.